your books to page 114. Now, as I was talking to you about the corner, cusp, vertical tangent, and discontinuity possibilities, and those are the most common situations you're going to run into where the derivative might not exist, okay? That's really all you need to know. That's all of them, all right? When we talk about those, and I told you about and the wording in the book is there if you need to go back and see it again, but I didn't have you write it down. The reason I didn't have you write it down is in all probability, if you're arriving at this algebraically, you're going to have to think about which case you're in, okay? If you have a graph to work with, you don't need to think about why. You just need to remember those 4 conditions, okay? So I want to demonstrate that for you through some examples we're going to do right quick. So let's take a look at number 2. And I'm not going to draw this on the board, but let's just talk it through. The directions tell us to compare the right-hand and left-hand derivatives to show that the function is not differentiable at the point P. Find all points where f is not differentiable. But when we look at the picture for number 2, we see a pair of line segments joined at that point between them, at the point 1, 2. Yes? Okay, so this is a corner, right? So what is the slope on the left? And it says compare the right-hand and left-hand derivatives. All right, so my right-hand derivative, let's do the left-hand first. What's the derivative of the first piece? Okay, on the left we have m equals 0, and then on the right we have m equals 2. So we have a corner at the point 1, 2, not differentiable, aka no derivative. In fact, I'm just going to abbreviate it. No derivative. That's all you have to do. Simple enough? Now, we also need to talk about number 4 in a little more detail. Why is 4 probably going to require more detail? Anytime, and I'm cutting you a break here because I could be really, really stringent and require that you use the definition of the slope of a curve to demonstrate those 2 slopes that I let you just write down by looking at it. When it's a line, or a segment of a line that comprises the graph, just like I told you with absolute value, just write the slope, all right? So on number 4, I'm going to make a note that m equals what on the left? 1, okay? So m equals 1 on the left side of the point of interest. And what is this point of interest going to be called? Why is P a point of interest? Because it is the cusp. Okay. You could argue that it's a corner, but it's not a corner because both sides aren't linear. So if either side's curved, you're going to call it a cusp. So we have a cusp at 1, 1. But now we have to give the slope of the curve on the right. Okay. So we got to do a little work there. So we're going to do it. But there's nothing to it because we're experts at it now, right? Yeah. Oh, this room reeks with sarcasm. F prime of x equals the limit as h approaches 0 of 1 over h times. Tell me what to write. That was tough, wasn't it? Y'all looked at me like you were going to panic there for a second. It made me nervous. All right. Minus 1. That was really sad. Minus 1. Okay? I said we're going to do this really fast, and you were like... We've only done this like 57 times, which we hadn't figured it out yet. Okay. How do I add a fraction to a whole number? We need the common denominator, which is in fact the only denominator, so that's going to be our common. And the first term is going to bring in a 1. Then I'm going to minus what? Minus 1 plus h. Listen to Will Condor back there. I might leave you in that corner. I hear from you more back there than I did up here. Not that you weren't, I'm going to keep going vertically instead of starting to go across the page. All right, so now what happens? I know somebody did not just say cancel. Yes, I heard you. I know who said it. I'm not going to look, but I definitely heard it. All right, so what's left in the numerator? Negative h over 1 plus h. It is not okay with me if you do your canceling on that last step all at once, because on that last step you should be combining your terms in your head at least. Okay? So now what can we do? Now we have something to cancel. The h's are gone. So now I can take my limit as h approaches 0, and I get negative 1. Clearly, the slope from the left being 1, the slope from the right being negative 1 indicates that we do not have a derivative there. Pretty simple? That should be pretty simple. If that's not automatic as you think about it and write it, you have not done enough work for Chapter 3 thus far, especially since we ended Chapter 2 where we're starting Chapter 3 with respect to the kind of work you have to do. It's very, very similar. Come on, board. You can slide down. There it is. All right. What is that noise? Stop it. Unless you'd like to go sit in a preschool class, I suggest you not do that. If you need attention, there are much better ways to get it. All right, on page 114, in exercises 5 through 10, the graph of a function over a closed interval D is given. At what domain points does the function appear to be A, differentiable, B, continuous but not differentiable, C, neither continuous nor differentiable? All right, so talk to me about 6 with respect to all of those questions in a general way. What is your assessment of the function in number 6 based on your knowledge of differentiability thus far? This is supposed to be a class conversation. And I'm pausing to let you talk in front of me. Do I need to leave the room again?
It doesn't look like one of the examples of ones that are.
So we don't see, you're saying you don't see anything that looks like a reason not to have a derivative, right? But it's not a whole function. Differentiable on the domain.
That was the number 9.
Okay, I'm trying to see evidence that you learned what you were supposed to learn from 3.1. In particular, where we ended our discussion of the homework items, we actually talked about the thing that should catch your attention here, that you need to give some thought to. What's the only part of the picture on 6 that I really need to give thought to? The endpoints, right? Do I have derivatives at the endpoints? Why? The closer I get to the left endpoint, my right-hand derivative would reach a value, yes? As a limiting definition. How about the right? Same thing, right? That's what I wanted you to say. Okay, so A, differentiable. Where is this thing differentiable? From where to where? -2 to 3. Now notice I did not put any symbols yet. But what symbols should I put? Why? Because by definition of our endpoints, we have derivatives in both spaces, right? Okay, both cases. B says continuous but not differentiable. Is there anywhere on here that this function is continuous but not differentiable? No, because if it's differentiable everywhere, there's nowhere it's not. Right? Logic, children, logic. Try some. All right, and then C says neither continuous nor differentiable. That's another NA, right? Didn't we just say it's continuous?
Too easy.
Yeah, too easy. I hear you. All right, that's where we're going to stop for the day.